All right, so we did not get to the definition of a depressed polynomial. So for a second, I'm going to go back to... Right? It's so relatable. So if I go back to example 3, when we got the x squared minus x plus 3, right? When we did our synthetic division, we found all the possible zeros. This was like our final answer. You with me? Okay, this is called a depressed polynomial. You know how, have you ever heard them say like that every subject has its own language? Would you guys agree with that?
Sure.
You haven't? Okay. So that's the thing. Like you take foreign languages, but also every subject has its own language. Like where else in life do you hear the words like automatopoeia, hyperbole, epistrophe, personification? Like where do you use those words? What? Literature and English, right? Like we don't talk about those things in math, right? That's a language. That's vocabulary that you only use in the subject of like English and language when you're studying in literature. Okay, so every subject, science, okay, in science, we talk about scientific notation. Oh, that's some overlap with math. We use scientific notation in math. Like there is some overlap in science, but we don't talk about herbivores and carnivores. We don't talk about all kinds of different things that you talk about in science. Like we don't talk about mitosis or meiosis or biodiversity in math, right? Mitosis is how cells divide. Okay. All right. And meiosis is another way that cells divide, but there's 2 different ways. One time you end up with a diploid cell, and other times you end up with a haploid cell. When do you learn this? In high school?
I didn't learn this.
Okay. But anyway, so every subject has its own vocabulary or its own language. All right. So I know that it's probably like, oh, when am I ever going to need to know this? In this class, like in the study of math, you need to know a depressed polynomial. So if we look at the definition, the depressed polynomial is the quotient of a polynomial divided by one of its binomial factors. Okay, so it's the x squared minus x plus 3 from the answer. So remember, in division, right, we take the dividend, hopefully you remember this, and we divide by the divisor. So see, math language, and we get the quotient. That's what it is. It's saying it's the quotient. When we take the polynomial and we divide it by a binomial, so in this case we have a polynomial, maybe that'll help us. We take the polynomial and we divide it by a binomial. And we get depression. You're right. We get depression. Ha ha. We get the depressed polynomial.
It's just under too much work.
It's true. But yeah, yeah, I could get it. You take a polynomial and divide by a binomial, you get depression.
Math things, and you get
It's true. All right. So anytime you see that depressed polynomial, they just want you to, if they're like, find the depressed polynomial, they just want you to do division. Okay?
Why can't they just say that? That's so stupid.
Because we have lots of names for all kinds of different things.
It's so stupid, though.
Why is it so stupid?
Because there's no point in having 10 different ways to say the exact same thing. It's just dumb and confusing.
Without half trespassing.
Yes. So, I mean, again, like if we talk about in English, let's compare it to literature. Okay, we have personification and anthropomorphism. All right, anthropomorphism. So personification, you don't know that? Okay.
No, I do.
You do that? Okay. So personification is when we do what?
Giving God physical attributes.
Well, anthropomorphism could be giving God physical attributes, yes. Mm-hmm.
Personification is where you give like inanimate objects. Personality.
Okay, so you give them, okay, so personification, you're giving a, like something, what'd you say? well, kind of a personality, or like personal actions, right? Like you're giving them something that they can do as a human. You're comparing them to a human, kind of. Okay, anthropomorphism is when you make something a human-like. So like Winnie the Pooh. It's not like we're saying he's like a human. Okay, Winnie the Pooh has clothes on, he has his own house, he eats food in like off of a bowl or a plate like a human does, right? He talks, he has friends. Like we are making him a human. Okay, so personification is small. Okay, anthropomorphism is like we're making the whole entity more human-like. Okay, the same thing, but you talk about like different names for all the same things. How many times in the Bible did God rename someone? How many names are there for God? Like, what? We see it in Scripture all the time that there are multiple names for the same thing or for similar things. And it is confusing. But we also see that that's how God, right? I mean, Scripture is God breathed. So that's how he gave it to us as well. So sometimes it adds more clarity later to have a different term for it than just the simple term. Sometimes we don't see it right away. All right. So let's actually get to the math. Doing some math. And let's do example 4. And factor p of x, remember that's a polynomial, equals 2x cubed plus 3x squared minus 1. All right, so first of all, is it telling us what to divide by? No, so this is where we have to make a list of the possible rational numbers. So that's that rational root theorem. Okay, so we're going to find our roots of, we want to find a p-value. What are our factors of p? Not -1 and -2, just of the, yeah. Positive or -1, right? Because we could do +1 times -1 is -1. Yes, but you can hang on to it and I'll answer it in a second. All right, and then we need to do, sorry, I wrote P again, and I can't erase. There we go. And then we need to do our Q. And our Q is what value? All right, so what's the Q of 2? What are our possible factors of 2? Okay, plus or minus 2. And 1, plus or minus 1. Right, because the way we, right, because the way we get 2 is we do 1 times 2. Well, yeah, so we could do 1 times 2. We could do -1 times -2. So both of those still apply. All right, good. So we made our list. How do we know what our possible zeros are then? Okay, so we're going to do P divided by Q? Yes, okay. So we need to do P divided by Q. And so what are our possible zeros going to be? Okay, what do you guys think? Is that right?
Or is it just the plus minus 2? Because the ones cancel, so I really don't remember how you did that.
Okay, so that's all right if you don't remember. Wouldn't it be 1 1/2, he says?
It's P divided by Q. P is only 1. But then you have a 2 for Q, so 1 divided by 2.
So plus or minus 1 divided by plus or minus 1. 1 divided by 1 is 1. And then we have plus or minus 2, or 1, you're right, yeah. Yes, because the Q goes on the bottom. It would be 1/2. Good catch. Yep. Good, so this would be plus or minus 1/2 for our possible. Mm-hmm. Yep. Okay, so I'm going to erase this work here so we have plenty of room. All right, so now that we have our possible zeros, we want to evaluate the possible zeros. I always start with the easier ones first, right? Like 1, positive and -1 would be the easiest ones. So let's evaluate our possible zeros. So we're going to do p of a positive 1 first. How do I do that, Ethan? I just plug it in. So I'm going to have 2 times 1 what? Okay, I'm going to erase this so we can see it a little easier. Okay. So 1 cubed is 1. 2 times 1 is 2. Plus 1 squared is 1. 3 times 1 is 3. Minus 1. All right, Brandon, what is 2 plus 3 minus 1? 4. All right, so is this a 0? Nope. Okay, so let's try the negative 1. Let's do our polynomial to the negative 1. All right, Brandon, can you put that one in there for us? Okay, so we're putting negative 1 in for all of our x values. Well, we want to do negative 1, right? Uh-huh. You got it. All right, so negative 1 cubed is what? Negative 1 this time, right? When our negative has an odd exponent, it stays negative because it's negative 1 times negative 1 times negative 1. So negative 1 times negative 1 is a positive 1. And now we have a positive times a negative, so it comes back to a negative 1. Anytime the exponent is odd, okay, it's going to keep that negative symbol. So we have negative 1 times 2, so negative 2. Negative 1 squared is 1. It's an even exponent, so it's 1. 3 times 1 is 3, and then minus 1. So negative 2 plus 3 minus 1. Josh, what's that? 0. Oh my gosh, we found a factor. Right, so negative 1 is a factor. Praise Jesus. All right, so what do we do now? Well, there's kind of some hints there to help us, but okay, yep, and so that's what the next one says. Use synthetic division. The factor that we just found. Negative 1. You're okay. You had a day off. It's all good. All right, so we're going to divide by negative 1. And we're going to check our exponents. We have 3, 2. Ooh, I don't have an x to the power of 1, do I? So I need to insert a 0x in there. Okay, so I'm going to have 2, then a positive 3, then my 0. Did you say a positive 0? Yes. And a negative 1. All right. I bring down my 2. And I'm ready to go. Okay, Brandon, get us started. What's negative 1 times 2? Okay, 3 minus 2. Ethan. All right, Josh, negative 1 times 1. All right, good. 0 minus 1. Brandon. Ethan, negative 1 times negative 1. Negative 1 times negative 1 is 1. And Josh, negative 1 plus 1 is 0. Okay, so here's the thing. We found out we should have a 0, right? That it would have a 0. We shouldn't have a remainder. And we just proved it right here. Again, it's like we double checked ourselves. If we got a number for a remainder, we should know that we did something wrong in one of the problems. All right, so then Brandon, it's your turn. How do I convert this 2, 1, negative 1 into an answer when we start with this polynomial? Remember, the key here is we started with x cubed. Yeah, we're going to have 2x squared plus 1 plus 1x minus 1. Hey, what's that called? 2x squared plus x minus... A depressed polynomial. Whoop whoop.
That's not.
But it is not factored, right? Okay, so now
You just have to do 2x squared plus x minus 1 times the quantity x.
okay, so we take our depressed polynomial and we multiply it by the binomial that we use, which would be x plus 1, remember, because this is the opposite. Because we divided by -1. Remember, if we go back, the formula was...
Why are we writing the same thing again?
Well, we had to write it as a factor, right? Because it said factor, so we have to write the polynomial as a product of the factor, or the binomial, and the depressed polynomial. But we haven't gotten here yet. What's up? Well, there's one more step here because it says factor the trinomial, which I've not had you all do yet. Because you also know how to factor the trinomial. That 2x squared plus x minus 1.
You can take x out of it.
Okay, so we spent all that time because now this part is a quadratic, right?
You're saying you can like what x out of that?
So since it's a quadratic, we know how to, like, it's not factored. The quadratic itself is not factored yet either. So we can do the, we can't just pull an x out of it. We can factor, we can use completing the square, we can do quadratic formula. Well, we're not solving it, that was factoring. Because before, the unit before this, we worked on we worked on factoring the quadratic. Now we're stepping up to the next one, which is the polynomial. The polynomial sometimes has a most of the time has a quadratic within it. So Monday we just worked on, okay, getting the polynomial down to its depressed polynomial kind of, or down to its quadratic, if possible. And so then we could simplify this one even further and factor it.
So how do we do one of those things without actually solving for it?
What do you mean without actually solving for it?
If you're just completing the square, that's taking a step to solving it.
Oh, okay, so yes, but we also learned how to just factor without solving and how to complete the square necessarily without solving. But this one I would just factor because we have small numbers, 2 and -1, right? So we would multiply 2 times -1 is -2. So what are the factors of -2 that get me a +1? Well, 2 plus -1, right, equals a +1. So then we would have 2x squared plus 2x minus x minus 1. So we're just taking that chunk. We group them. Is this coming back to you guys?
Yep. So then we can take out 2x from each of those.
All right, so we can take out a 2x. And so 2x squared divided by 2x is x. 2x divided by 2x is 1. We're going to take out a -1 from the other side. So -x divided by -1 is x. -1 divided by -1 is a +1. Okay. So then we're like, oh, well, we're doing 2x times x plus 1 and -1 times x plus 1. We're multiplying them by the same thing, so we can just combine them and have 2x minus 1 times the quantity x plus 1.
But x plus 1 is also up there.
And x plus 1 is also up there. So this replaces this piece, just that quadratic. So your final, you could write it as that. Your final is then 2x plus 1 when it's completely factored times the quantity x plus 1 times the quantity x plus 1. Or, as Josh said, these two are the same, so that would be squared. 2x plus 1 times x plus 1 squared is another way. These are the completely factored, like all the way done. Okay, and that's why I said like we hadn't quite gotten there yet. let me insert in here, this would equal P of X. To actually have it all together. That is an X. So you could write it as either of those. And that doesn't look like an X. But that's all the way completely factored, nothing else left. Okay, so we're going to keep up with this, but now we have two patterns are combined into a single statement that's read across the top or the bottom, and we have the plus or minus and minus plus symbols here. Okay, let me see if I can tidy this up a bit. It looks a little fuzzy. There we go. It got fuzzier to get better, right? Okay, so this is the sum and the difference of cube factor patterns. So when you see numbers that are in this pattern, a cubed plus or minus b cubed, it does not matter. So like here, if we look here, if we just have this x cubed, we should look for a pattern if it's only two numbers, because it's still a polynomial, even though it only looks like 2. Okay? And the way that we do this is it says we read across the top or the bottom. So if we read across the top, we're going to have a plus b times the quantity a squared minus ab plus b squared. That's this one, right? Where did what come from?
Extra stuff.
Because instead of making you do all the work, they're showing you this short, like this is the factor pattern that we get to get a binomial, okay, and then a trinomial here. So this is the shortcut because we see the cubes, and instead of you having to do all the work for them, this is the shortcut when you see a cube. They already did all the math, and you're just like, yes! Right. And so, and like this is the formula that you'll see, but you have to realize that you read it across the top. So a cubed plus b cubed is gonna, if I have a problem like this, it's going to simplify to be a plus b times the quantity a squared minus ab plus b squared. So I just wrote it separately out there. Where if you read it across the bottom, you're going to get this one. So if you have an a cubed minus a b cubed problem, you're going to have the quantity a minus b times the quantity a squared plus ab plus b squared. It's just making sure you understand how to read the shortcut. Okay? Oh, nice. Okay, so this one right here is a plus no matter what, right? The rest of them, we have a plus minus, or a minus plus. Okay, we've always written it as a plus or minus, but there is a, just when you're reading them across the top. Like in this case, if we read it across the top, we have to have the minus in there.
Oh,
that's
so
it.
here it's not saying this can be positive or negative anymore. It's saying you're reading it two different ways.
Right. So instead of making you memorize two different formulas, you can condense them. We can condense them into one.
So it's saying,
and you still get two.
If you remember positive or negative, positive,
Yep.
then you can always get to either one of those.
Correct. Yeah. Okay. So okay. So yeah, let's take this. So in order to be helpful, because 64 is not in this form of b cubed, so we want to change that to figure out, well, what is it? So x cubed minus 4 cubed is equivalent. Okay, if you find the cube root of 64, it is 4. Okay, so 4 times 4 times 4. 4 times 4 is 16. 16 times 4 is 64. You believe me? Okay, fantastic. So now we can say, all right, well, x is equal to my a value in my formula. 4 is equal to my b value in my formula. And is this a plus or a minus? It's a minus, so we need to read along the bottom in order to factor it. Okay, plus AB plus B squared. Okay, so far are we good that we're using this formula?
So it's just taking out the parentheses and putting it in the appropriate positive.
Yep. Where you mean taking out the A and B, you mean? Well, here I just said, okay, this is my A and my B, and I said this is subtraction, so it's this formula. It's reading along the bottom, so it's the same. We're doing this one right here. So I just copied it down. Are we good with that so far? Picking which one? Okay, so now we're ready to plug in our values. A is equal to X. So our actual answer is X minus, what's our B? 4. So X minus 4 times the quantity. What's our A? A is actually X. So we're going to have X squared plus X times 4. So I'm going to reverse that. We always write the coefficient first, 4X plus B squared. So I'm going to go ahead and write B 4 squared. Are we good? Are we confused? Okay, so everywhere there was an A, okay, we put an X. So A, we put an X. A, we put an X. A, we put an X. Everywhere there was a B, our B is 4. So we put a 4 in the formula. The only thing that changed is that I changed the order of these because we always write the coefficient first. Does that help? Okay. All right. And then, so here we would take this one step further, or we could take it one step further and simplify 4 squared and make it 16. That would be the ideal, okay, because none of the others simplify, right? But we can't do any more math except for that 4 squared, and we can make it 16. We just factored it. We found the binomial and the depressed polynomial that we multiply together to get this polynomial. Yep. Yeah. So instead of having to do the rational root theorem, right, and find all the possible zeros and then evaluate the possible zeros and all that stuff, we were able to take this shortcut and be like, oh, it's actually this one because it's the difference of cubes. We're going to stop there.
So you're saying if you get, only if you can only do that if you get, your answer is X cubed.
Yes. Yeah, only if you have an X cubed one. And it has to be a difference of cubes. So this number has to be cubed and this number has to be cubed, which is what we proved right here. X cubed minus 4 cubed.
So basically,
so in the next one, we're going to apply the same thing. Like we're going to, it says apply the cube factor pattern. So we know this has to be a cube. So what's the cube root of 8? What times itself again is 8? 2. So if we're looking at this, this is going to be 2c cubed plus, what's the cube root of 27?
It's not a cube, that's a 6.
Well, but I'm looking at the 27 first. I have to find the cube root of the whole thing in order for it to follow a cube pattern. So 2 times 2 times 2 is 8. 3 times 3 is 9. 9 times 3 is 27. So this is 3. What's the cube root of d to the 6th? D to the 2nd. So this would be d squared. And then that value is cubed. So if we cube, because this would say 2c cubed is 2c times 2c times 2c. Well, 2 times 2 is 4, 4 times 2 is 8. C times c times c is c cubed.
So it's the same thing.
It's the same thing. We're just, right, but because we have to get it into this cube pattern so that we can follow this pattern and use it. That's where it's tricky, because like sometimes if you look at this, if I didn't tell you to use a cube pattern, you may not know that it's a cube. Okay, it's harder, especially this 27d to the 6th. But in that case, like this one, we would do 3d squared times 3d squared times 3d squared. 3 times 3 is 9. 9 times 3 is 27. D squared times d squared times d squared is d, and then we always add exponents, so d to the 6th. So 27d to the 6th. We got the same thing. We just had to undo it to get the cube pattern. Okay. Can you wait until this one's done? Okay. All right, so this one is addition. So we're going with reading the top pattern. So my A is the 2c, and my B value is 3d squared. All right, so let's try this. We've got AC cubed plus 3d squared cubed equals, all right, what's my A? 2c, so it's going to equal 2c plus, what's my B? Plus 3d squared. Close my parentheses. Now I want A squared. What's my A? Okay, so this is where it can get tricky too, because it's 2c squared in parentheses, right? Or, sorry, the 2c is in the parentheses. I even wrote it wrong after I said it can get tricky. Because I'm squaring the 2c, not just the c. Minus, my A value is 2c. 3, okay, 3d squared. Okay, so we'll get there in just a second. And then it's plus, I'm running out of room, so I'm going to have to write it down here, plus b, what's my b value? 3d squared. So it's plus 3d squared. And I'm going to close my parentheses.
No, it'd be 3d squared squared, so it'd be 3d to the 4th.
Oh, thank you. Sorry, I was... Okay, but it's not 3d to the 4th. No, it's 3d squared squared. So that's what I'm talking, or that's what I was saying about. So 3d squared goes in my parentheses, and then I have a squared outside. Okay. So the binomial there, we don't have to do anything. It's just 2c plus 3d squared. 2c squared. So what's 2 squared? 4. What's c squared? C squared. Okay, minus 2c times 3d squared. What's 2 times 3? 6. And then c and d we can't do anything with, so we just leave it as cd squared. Then we have 3d squared squared. So what's 3 squared? So plus 9d squared squared. D to the 4th. Okay. Very nice. I hear you. Oh my gosh. Like literally putting like polynomials put every single thing you've ever learned in math like all together. Okay. How do we feel about that? You hate it. Are you depressed? Okay. All right, we're gonna stop there and let you get started on your homework.